Hello, this is Daniel Cushy with Decisive Edge's Data Science team. In this screencast, we'll be presenting just a few of the many features and functionalities offered by Microsoft Azure's Databricks Cloud Computing Environment, a unified analytics platform. Databricks is a service that automatically configures instances of the distributed computing framework Spark for easier usability. This is a Databricks notebook in Azure. We've chosen Python as our base language, so we'll be using PySpark for distributed data manipulation. We're also using a CPU cluster, though we could have just as easily spun up a GPU cluster for deep learning projects. For this demo, we'll be using a relatively small dataset of player statistics from the game FIFA 19. Let's start by reading in our data. The data is held in Azure's scalable data storage repository known as a data lake. Here we have the mount point set up, where we can access the data from the data brick. Now let's take a look at the data. As you can see, most of this is useless or unusable, so we'll now perform some feature conversion and reduction to make the data useful in later analysis. And here's our engineered data, where the age column is binarized at the age of 30 and renamed label, so that we can predict whether or not players are over the age of 30 based on their skill statistics. From this PySpark data frame, we now create a delta table, which we'll call FIFA. Delta tables are a Databricks product which serve as permanent tables, so they persist across clusters, notebooks, languages, and users, and they have several added functionalities aimed at improving recall, memory optimization, and data integrity. We can query our data in SQL, Python, R, or Scala, but let's start with SQL. To begin a SQL code chunk, one only needs to use the SQL magic command as shown here. Now let's query the data in R using some non-Spark native libraries like tidyverse and sparklyr. We can plot the data in memory using R's ggplot library, or we can plot out of memory using Databricks' built-in plotting functionality. Let's read the data back into Databricks as a PySpark data frame for some modeling and analysis in Python, with the benefits of it being in a delta table. We'll be using Spark's vast ML library to perform our logistic regression modeling. Note that in the interest of time, I've already removed several insignificant feature columns. If you'd like to know more about how this was done, just ask any of our data science team members. The logistic regression produces a model with the displayed coefficients and an AUC of about 0.96. Now that we have a working logistic regression model, let's optimize it using Spark's MLlib to perform a parallelized hyperparameter grid search and MLflow to track the progress of the search. MLflow is an integrated component of the Databricks machine learning environment, where all metrics produced by MLlib functions will automatically be recorded and tracked so that you can view results later and choose the best model to your needs. Here we can see MLflow's chosen optimal hyperparameters for our model, and choosing a model is even easier with MLflow's UI, where we can view graphical representations and in-depth statistics comparing any previous model runs and their metrics. For instance, here, using a regularization parameter of 0 and basically any elastic net parameter results in the highest AUC value. That's all for now. I hope this has demonstrated some of the features available in Azure's cloud computing environment. And if you have any questions, please don't hesitate to reach out to our data science team.